Hello, beautiful people. This is part 2 of your practice test for our Unit 6A. Now, as always, if I make a mistake, I am human. Please let me know where the mistake occurs so that way I may learn from it. Let's go ahead and get started. On question 11, this is asking us to sketch the graph of each function. Now, this is an exponential function, so we have our vertical stretch or compression, we have a reflection, and we have our horizontal shift and our vertical shift. So looking at this one here, we have a vertical stretch of 2 and a reflection across the x-axis. We have a vertical stretch by a factor of 2. Here we have our h, which is our horizontal shift. So we have, you can say shift left 2, since left is horizontal. And then the last one is we have a vertical shift down 2. Now, if you look at the b value, or this value right here, this will tell you if you have a growth or a decay function. If this, in this case, we have 2, so this is your growth function. So let's go ahead and give this a sketch. You're using your h comma a plus k for your first reference point. Your secondary reference point is h plus 1 comma a b plus k, because this is a growth function. Now this secondary point would change if you have a b value that is less than 1 and greater than 0, like a fraction. So first one, we have h. Again, think opposite for h. We're doing minus 2 comma a is negative 2 plus k is negative 1. So lots of negative numbers here. And for our secondary point, we have negative 2 plus 1, comma, negative 2 times our b value, in this case 2, plus our k value, in this case a negative 1. So I'm going to use my calculator. Actually, I don't need a calculator. So the first reference point is negative 2, comma, negative 3. Secondary reference point is negative 2 plus 1, which is negative 1. And then we have negative 2 times 2, which is negative 4. Negative 4 minus 1 is negative 5. Now we're also going to find our y-intercept. For our y-intercept, you're going to set x equal to 0. And you're going to solve. So we have negative 2 times 2 squared minus 1. Negative 2 times 4 minus 1. So 4 times 2 is negative 8. Negative 8 minus 1 is negative 9. So that means I'm going to have a y-intercept at negative 9. Let's go ahead and sketch. I'm going to sketch this out here. Again, it doesn't have to be perfect. We also need to identify what our asymptote is. In this case, our k value is negative 1. So that means our asymptote is at negative 1. For our asymptote, it needs to be a dotted line because it technically doesn't exist. Still a line, so it needs arrows. So we have 2 points. I have a negative 2, negative 3. I have a negative 1, negative 5. 1, 2, this is negative 1, 2, 3, 4, 5. And we have a y-intercept at 0, negative 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's think about this just for a quick minute. We have a growth function, so it shoots up like this if a is positive. Since a is negative, we're going to have a growth function that shoots down this way. So that means we are coming super, super, super close to our asymptote on the left-hand side, but on our right-hand side, we're going to go exponentially down. So for our end behavior, as x approaches infinity, as x gets really, really big, y gets really, really small to negative infinity. However, when x approaches negative infinity, y approaches, it gets super duper close to a negative 1. When you are graphing, you need 2 points, your reference point, 1, your secondary reference point, and then the third point that you need is your y-intercept. Sometimes you'll have one of the reference points be the y-intercept. In that case, you get lucky. All right, let's do this. Write an equation for each graph. So for this one here, you're going to write an equation. In this case, just like before, we got to determine if this is a growth function or a decay function to know which formula to use. And in this case, we have a decay function with a reflection across the x-axis. So that means we're going to have a fraction for our b value. However, our a value is going to be negative. So when we're here, we're going to have 2 reference points. Now, when you are given this on a test, I will give you your 2 reference points so you have an idea. So we want h comma a plus k, and since this is a decaying function, this is going to be our h comma a plus k because our secondary is h minus 1 comma a over b plus k. So we're going to use h comma a plus k. So h comma a plus k, I'm writing that down below. And that point is at negative 3 and what is this? Negative 3 and negative 3. So that means h is equal to negative 3. That means a plus k is equal to negative 3. And we also know that k value is our asymptote, in this case, 1. So I'm going to continue solving. So I have a plus 1 is equal to negative 3. I'm going to subtract 1. So that means a is equal to negative 4, which again, I'm doing a happy dance because we already determined a should be negative. Looking at our equation, y equals a times b to the x minus h power plus k. We determined that a is negative 4. B we still don't know. X minus h is negative 3, so we're doing a plus 3, always opposite for h. And then our k value is a positive 1. Now to find what your b value is, you're going to take your secondary point, and that's going to be your x and y values. So our secondary point is negative 4 and negative 7. So x is negative 4, y is negative 7. Plug that in and solve for b. So I have negative 7 is equal to negative 4 times b to the negative 1 power plus 1. I'm going to subtract 1 first. So I have negative 8 is equal to negative 4 times b to the negative 1 power. Literally running out of room here, but that's okay. Divided by negative 4. Negative 8 divided by negative 4, that's positive 2 is equal to b to the negative 1st power. So again, the negative just means that b is a fraction. So this is what I have. So what we're going to do is we're going to create 2 fractions, flip both fractions. So b is equal to 1/2. And again, that makes sense because we have a decaying function. We have a decreasing function. All right, so what is our final answer? Our final answer is y is equal to a, which is negative 4, times b, which is 1/2, to the x plus 3 power plus 1. And that's going to be your answer. All right, let's go ahead and continue. For number 13, it is asking for you to graph the following. Now this one, they did give you a multiple choice selection. So it's a little bit easier, but it's the same thing as we did before. E's value is about 2.72-ish. It is an irrational number, so it continues forever and ever, but it's about 2, meaning we have a growth function. Meaning we have h comma a plus k, and we have an h plus 1 comma a. Instead of b, because we have e as our base, we're just going to put an e here plus k. So h is 7, a is negative 3, plus k is 2. We're going to add 1 to that, so 7 plus 1. And then I have negative 3e plus 2. So for our very first one, we have 7 comma negative 1. That's our first reference point. Our secondary reference point is 8 comma negative 3e plus 2. So it's about 2.72, but I like to use my calculator and get as exact as possible, even though we are still going to be rounding. And that's about negative 6.15. Looking at our k value will tell us the asymptote, which is 2. And then looking at our e value, we know it's going to be a growth function. So growth function when a is positive. If a is negative, then you have a reflection across the x-axis. And so in this case, a is negative. You see that a is negative. So that means we're going to have something that looks like this. So immediately looking at my selection, let me zoom out. Immediately looking at my selection, I know this one can't happen because it doesn't have that reflection. Looking at the other, so one of these three options. Let's check our first, 7, negative 1. 7, negative 1. This is definitely not a negative 1. 7, should it be positive 1 or negative 1? 7. Oh, you know what, you guys? I thought this was negative 7, so it's a positive 7 and a negative 1. So this one still doesn't work. So positive 7, negative 1, there should be a point there. There's nothing there. Positive 7, negative 1 should be a point here, nothing there. Positive 7, negative 1, there should be a point here, and there is. So that means our answer is D. Let's continue. On this one, it says write the equation for each graph. And this one's a little bit tricky. I didn't mark up the points. However, there should be a just a regular exponential function, but that's okay. So let's go ahead and I'm going to give you the points now. Let's see. Let's make it this one. This one looks pretty. And let's do this one. This one is a decay function, right? We have growth. We have a decay. So we know that this is going to be, A is going to be positive. And I'm actually going to write this a little bit off to the side because it looks like I have a word problem here that will need to take up some space. So I'm going to do this on this side. And again, I am simply looking at this here. So my first point is h comma a plus k. This is a decay. So our secondary point is h minus 1 a over b plus k. And I'm actually going to show you a different way to solve for b instead of using a point on this one. So h is, make sure that you're using the 1 because if we go 1 to the left, this is your h minus 1 point. This is your h comma a plus k point. Make sure you got the correct points. So this one is 1 and 3. The secondary point is 0 and 17. Our asymptote, if you're looking at your graph, our asymptote is at 1. So your k value is 1. So that means h value is 1. A plus k is 3. So a plus 1 is equal to 3. Subtract 1. A is then equal to 2. And again, we are doing a happy dance because we should get a positive value since there was no reflection. So we have a k value, we have an h value. Now this is another thing that I'm going to show you to do for solving for b. You can do this instead of doing the x. Just like we set a plus k equal to 3, I'm going to set a over b plus k is equal to 17. We know that a value, we know the k value. So then we're just going to be left with b. So a is 2, k is 1. So let's solve. So I'm going to subtract 1, subtract 1. So I have, what is this, 17 minus 1, that is 16. I have 2 over b. Now be careful, do not multiply or divide by 2. Your variable b is in the denominator, therefore you're going to have to either multiply by b both sides or create two fractions and flip it. I'm going to choose to do this, so I have 2 is equal to 16 times b. I'm going to divide by 16, so I have 1/8. So then what does our final answer look like? Y is equal to a, which is 2, b, which is 1/8, to the x minus 1 power plus 1. And again, make sure for your h values, you are doing the opposite of what you see. All right, I'm actually going to go ahead and pause it. There will be a part 3. Part 3 will be all about compounding interest, growth and decay, formulas, and things like that. Enjoy the rest of your day, and I will see you in the next video. Bye!